All right, we're about to take a look at OSPF, but do we need more than Area 0? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
OSPF areas? We don't need any other areas. We have Area 0. But I think Anthony's about to tell us something different. All right, Anthony, I have Area 0. All of my routers are working. I've got adjacencies. Everything's good. I'm done, right?
Yeah, that's right. Why have, well, first of all, what is the deal with areas?
Yeah.
Seriously, like in so many designs you might experience, it's just the backbone. And that is going to be fine unless you get into a larger enterprise. So I was really glad to see in the Encore blueprint, which is really targeted at the larger enterprise, that we had the mention of OSPF areas. This enhances your scalability.
Right.
I remember reading Cisco was very hesitant, just like Juniper and HP and all these router manufacturers were. They were very hesitant to give any guidelines on when would you need another area than just having the backbone. And I believe I saw Cisco finally mention like 50 routers. And then sure enough, everyone started beating them up over that recommendation.
Right.
So you could just imagine them going, well, that's why we didn't want to say any number, you know? So we would certainly be monitoring with our careful, use of show commands to see when, from a scalability perspective, we really want to consider another area. Some engineers go, oh yeah, you always do it. Like their theory is just start building for scalability early on. And then if you ever do need it, it'll be there in place for you. So it's a really great tool that we have in our tool belt. And this is going to enable us, by the way, to see those other LSA types that Ronnie was alluding to. If we jump on our equipment here, just to remind you, if you're not watching these episodes back to back to back, maybe, just to remind you of what we're looking at is just a very simple 5-router topology. In our previous episode, we built Area 0 using these bottom devices. So let's take between 1 and 2 and create Area 12, and then between 5 and 4, Area 54. Area 54. Is that what's out in the desert that has the aliens supposedly?
I think it is Area 54.
It might be Area 54, right?
Yeah.
Area 51?
51.
Is that what it is?
Yeah, it's probably, yeah.
All right, good thing we're not building that area.
Yeah.
All right, so let's jump over to R1. Let's see this configuration because we would want to know how to do this configuration. So we're just going to do, and we've demonstrated both styles of config. I'll just do my favorite. I'll do show IP interface brief, and then I see the interface IP addresses, and I go router OSPF 1 network 10.0. Let me get that spelling right. Network 10.0.0.5, my all zeros wildcard, and this is Area 12. Do you think muscle memory kicks in oftentimes and you just automatically do Area 0?
Yes.
Yes. Yeah, that happens a lot. So get ready to be flexible with that. It's one of the exam authors' favorite things to do with Cisco systems. They'll do this. They'll say, Ronnie, I need you to create OSPF on this router and peer with that router, and I need you to do process 10, process ID of 10. Ronnie goes, oh yeah, no problem. Router OSPF 1.
Yeah.
And then he's wondering, why did I get points off in that area? Because muscle memory kicked in. I'm going to do network 192.168.0.1. And that is going to be Area 12 as well. So we end, we save. Nothing really I'm going to verify there yet. I'm going to go down to R2 now. And on R2, I'm going to do show IP interface brief. And we're going to see our addressing scheme there. And I'm going to go in with my router OSPF 1. I'm going to do my network statement. It will be for the 10.0.0.6 and my all zeros wildcard mask. And I'm going to say area 12. And I'm going to have another one of those moments here of Zen where I go, what should happen when I press enter? Well, because I have the R1 device configured for area 12 and there's a match on the area there, we should get an adjacency up with the R1 router, and boom, there it is. Would I do any additional verification of that? No, honestly, I wouldn't. I think that's like wasting time. I'll see students that get this message and then they do show IP OSPF neighbor, and it's like, why are you doing that? You just saw that you get the peering.
Now, I have a question as it comes up,
Sure.
because some of the things that I have also learned, and people say best practice, would be to set the router ID and allow those to come up. Is that probably a good idea, at least for logical consistency?
Yeah, in production, we often are definitely going to hard code the router ID, Ronnie.
Okay.
Great point. In an exam environment, I definitely would not do it.
Okay.
Do not do it unless asked. Yeah.
Okay.
Yeah. If they give any kind of hint that you need to do it, then do it. But I call that over configuration.
Right.
And the only thing that can do is hurt you, really, not help you.
Right.
So, yeah, be aware of that.
All right, so Anthony, we've now set up our next area, and
Yep.
all these areas, as far as I can remember, they have to connect directly to area 0. Okay?
That's right.
So that's kind of one of the keys in making sure that we cover the idea of the common area type.
That's right. And in our topology here, remember, we have these areas that we're putting on those like kind of those
Legs.
pillars. Yeah, the sticks on each side heading north south. That area that is making that connectivity with the backbone. And we had mentioned it in an earlier episode that if you don't have that connectivity, you can go in with what's called a virtual link. You could do it other ways too, like a GRE tunnel, but you gotta get that connectivity to the backbone in OSPF or it does not function. So Ronnie, I guess for completion's sake, I will just go over quickly and do the other area, but we already should have the different LSA types. But real quick, let's just finish this config. So I've got the gigabit Ethernet 0/2 that leads off to the R5 router. Let's do this the other way. Interface gigabit 0/2, and I'm going to do IP OSPF. It's process ID of 1, but the area is going to be 54. So there's our command there. We're going to end, we're going to save, and we're going to slide over to the R5 device, and we're going to go to the 0/1 over on that side, IP OSPF 1, area 54, and we need to do the loopback as well, IP OSPF, or you can just hit up on the keyboard, hit enter, hit end, and if we did this right, we should see a peering come up between the R5 device here and the R4 device. If it doesn't come up, well then we are going to be exploring with the show commands to troubleshoot.
Yeah.
And
So-
I may have to do that, Ronnie.
Yeah, so it may be
Not coming
possible here when we start doing this, but let's try to remember that what we're also doing as well. So when we actually create those multiple areas, we're really limiting at least the number of OSPF messages that are going to go across to all of the routers running OSPF, right?
Absolutely. The smaller we make our areas, number one, the less overhead due to OSPF. And the other thing that we love areas for with OSPF, Ronnie, is they are going to create natural points at which we can summarize. You know, so we're going to do like variable length subnet masking is a great idea. And so you have these further subnetted areas with VLSM, and you can make those OSPF areas. And now you have an area border router which is a great place for you to do summarization of your prefixes.
So this almost goes into the area of design, right? Having a well-designed IP addressing scheme when you're creating multiple area OSPFs might really help in the
Yes,
efficiency
indeed.
of things.
Yes. And we're at a great point in our demonstration here. We're on R3 now. Both of those areas came up, Ronnie. It was a creepy delay over there on 5. I'm like, whoo, we were about to do some serious troubleshooting. Then all of a sudden it came up. My lucky day. Show IP OSPF database. Again, a command that's centered really all around learning for us here. We're not troubleshooting anything with it. And look at this, Ronnie, and to our audience out there, do you see anything that wasn't there before?
Yeah, so in our previous episode where we were just configuring area 0, we really saw, of course, the type 1 LSAs at the top, and then we saw the type 2s. But now on this particular router this is R3?
This is R3,
Yeah,
yep,
on
right
R3.
in the middle of the backbone.
Yeah, we're actually seeing that summary net link states, and that one for us is going to be that type 3 LSA.
Type 3, yep.
Yeah, so with the type 3 LSAs, this one comes from the area border router. Right?
Yeah, this is,
A summary.
yes, this is the summary LSA. And this is your type 3. This is an area border router thing. This is the first of the LSAs that is leaving an area. And if you look inside here, Ronnie, it makes perfect sense that the 192.168.04 router advertised to us the 192.168.05 address space. And we can see that in the routing table. Show IP route OSPF, we have an inter-area route entry for OSPF for 192.168.05. So the ABR, look at this, the ABR, the area border router that was R4 was responsible, thank you very much, for advertising to us a key prefix that was out in that normal OSPF area.
Yeah, this is kind of neat because this is where the point I was making with the well-designed OSPF scheme, that the area border router allows us to actually create as many subnets as we want in that one kind of well-addressed scheme. And then through that area border, we only have to advertise a summary, I got to make sure I say that right, into the backbone area, and that reduces the routing tables inside that backbone area, making it much more efficient.
Yep. And let's have a little more fun here because we have time. Let's do external OSPF prefixes. Why not? So let's see another type. I should be in the plural. Let's see some other types of LSAs that we're going to be potentially working with. So to create an external domain, you don't need to add a router or anything. You can get super creative. Let's go over to the edge of the world here that we've developed. That's R5. And over on R5, let's create a loopback 100. And I'll address this as 100, 100, 100, 100. And let's go ahead and, how do you want to do this, Ronnie? There's so many ways we could do it. I suppose we could run like EIGRP on this loopback interface, right?
Yep.
All right, so let me exit. We'll do router EIGRP 100, and then we'll do network 100, 100, 100, 100. They let us use a wildcard mask now in EIGRP. I love it. And I always do this, right? I'm always paranoid about automatic summarization. So it's just like by default, I turn that off. Okay, so great. There's EIGRP. Now what I'll do is exit out of that configuration mode. I will do my router OSPF 1, and I'm going to say redistribute. Go ahead and redistribute into OSPF EIGRP AS100, and then notice I'm using context-sensitive help here. Oh yeah, you got to use the subnets keyword in order to get subnets to redistribute, Context sensitive help. Looks like that's all I need to do. So I will hit carriage return. We are now going to end. And now we're going to go back over to the R3 device. And first of all, let's take a look at that routing table. There you can see what we had before. We rerun and we should see a type 2. Type 2 is the default external prefix for the 100, 100, 100 network. And what does this look like in our database? Well, let's find out. Let me up arrow, show IP OSPF database. We're going to see that we have a summary ASB LSA type. This is advertising the location of the autonomous system boundary router, the ASBR. R4 is saying we have an ASBR and it is 192.168.05. And then we have our type 5 LSAs, and that is the actual prefixes that are coming in from that ASBR. Remember, really important point. There is an LSA to advertise the existence of the ASBR. And then, of course, there's the LSAs for what it's advertising to us.
Yeah, now here's where the scope changes, where we were talking about LSAs type 1 and type 2, where they stay inside of the area. We've then talked about the type 3 LSAs that really allow us to go between areas. But now with both of these that we're seeing, this actually affects the entire autonomous system that we're in. So these particular types of LSAs go across the entire system, which again expounds that boundary of where we can actually reach.
Yep, great stuff. And this now is a great time for us to talk about special areas. We're not asked explicitly in this blueprint to discuss special areas with you, but it's impossible not to. This is just a great point at which to consider that, oh, okay, well, special areas are just really going to be specialized to automatically filter out certain stuff. So when we have a stub area, we're like, oh, yeah, don't bother us with certain LSA types. That's really what's happening. So the special areas that we get into of stub and totally stub, and then the hilarious one,
NSSA.
not so stubby, totally stubby area,
areas.
all these crazy things. It's all just automation on filtering for those LSAs.
Yeah, so there's a lot of these LSAs, and there's a lot of this that we have to know if we don't know them yet. So go through and create a lab like this as we kind of, as you actually start doing this. Take a look, go ahead and verify through the different areas if, the things are actually working the way that we need to. Type 1, Type 2 within a single area. As you start moving to Type 3, you start seeing where you actually go between areas, and those advertisements should be there. And then you go to Type 5, Type 5 and Type 6 and Type 7s. Those pretty much go across the entire autonomous system that you're in.
Yeah.
So you should be able to see all that, and hopefully that type of summary helps.
Yeah, I love it. Like Ronnie said, do what we're doing here in the studio. Just, I made up let's do a 5 router and a 2, and then just do it and see it. And do me a favor, the minute you have a question, post it for Ronnie and I in the Q&A forum. Don't be totally confused and then just suffer along. Now, obviously, I totally get it. You're probably like me where you're like, all right, I'm figuring this out for myself. But the minute you hit that point of, oh, I just want to give up, definitely look us up in the Q&A forum.
All right, Anthony, well, thank you for helping us to understand that. And I added in an area that we don't really talk about, Type 6, because that's not supported by Cisco routers.
That's why I was like, Type 6.
Yeah, that was just me kind of filling out the rest of that, and I was like, I shouldn't have said that. But yeah, there are Type 6s, but they're not really supported by Cisco routers.
Yeah.
So remember, areas 1, 2, 3, 4, 5, skip 6, and then Type 7. Those are the ones that we really want to make sure that we
And there's other ones too.
As well. And then Anthony also showed us, of course, the inter-area or the additional areas that we can add in. He even talked about stubby and not so stubby and some other totally stubby types of areas as well. Well, that is enough for OSPF areas. There is more to come, so stay tuned right here. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm totally stubby.
All right, take a break, and we will see you in the very next episode.
Thank you for watching IT Pro TV.